Today we're going to talk about inverse relations in functions. The big idea behind inverses is basically switching out the x and y values. So if we take a look at this relation here, and we've got some x values and some y values. For the inverse, all you simply do is switch out the x's and y's. That's not switch. How about this? Swith? No. How about switch? Switch out x's and y's. Now, all you have to do from there is determine whether or not it's a function. If you recall from earlier chapters that when you had a one-to-one relationship, like this one does, one-to-one, 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 that this relation actually is a function. It's a specific kind of relation. The inverse, we'll check to see if it's a function. This has one-to-one and to another. So this is a 1-to-2 scenario. So this inverse, not a function. Not a function. So let's go ahead and practice this idea down here with this little setup. If you look at all the x's and y's and the inverse of it, all they've done is gone ahead and switched out the x's and y's. This is your x column for the relation. The switch out, it's now the y column. In the relation, here's the y column. It's now been switched out to the x column. So the big idea for inverses is that you're switching out the x's and y's. Let's take a look at graphs of relations. Here is a relation, and you'll see that it passes the vertical line test for all of these. That's fine. And by reversing the ordered pairs, in other words, going back and switching out the x's and y's, you'll see that you get an inverse of this. And the other thing to check again is if it's a function, it passes the vertical line test. So this inverse actually is a function. Let's move on. Let's take a look at this relation t, and we want to find the inverse of t. Well, here are our x values and our y values. Again, the inverse, switch out the x's and y's. So really this is going to become y, and that's going to become x. So let's fill in all the x values. And then put in all the new y values. Let's take a look at the graphical or the pictorial representation of this. We've gone from 0, -5, 1, -4, 2, -3, 3, -3, here, 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 to these new points here. Let's see if it passes the vertical line test. This first one passes the vertical line test. They do not cross the vertical line twice. Passes a vertical line test, passes a vertical line test, now fails the vertical line test. So this inverse, not a function. Let's take a look at finding an equation for the inverse. Again, switch out the x's and y's, then solve for y. So they've given us this function, y equals x squared minus 1. And they want us to find the inverse. This is a great note to take. Switch out x and y, then solve for y. Here was the original. And then the first thing is they switched out the x's and y's and then began to solve for y. They added 1 to both sides, then got rid of the square by taking the square root of both sides. And they also remembered that when you take the square root of both sides, you are now taking into account the plus and minus of that. We have solved for y. We have found the inverse. So let's take a look at this next one. What is the inverse of this function? Well, again, take a look back at our notes, switch out x and y, then solve for y. Fine. We're going to switch out x and y, so we're going to have x now equaling 2y plus 8. Sorry about that, that should be 2y. Then solve for y. Subtract 8 from both sides. Then divide everything by 2. And that is our inverse. Take a look at the next one. What is the inverse of this relation described here? Again, switch out the x and y's. Then solve for y. So far, so good. Now let's graph this relation from the first problem. Let's go back to that first problem here. Oh, sorry, I went too far. We're going to go ahead and graph this situation right here. All right, we'll get those out of the way. Another way of looking at the inverse is that you are really flipping the graph over this handy dandy little purple line, which is the graph y equals x. When you switch this from this side to this side, you're making the x's now y's and the y's now x's. So every time we have a graph, we're really flipping it over this function right here of y equals x. So let's suppose we had y equals x squared minus 1. Now, for those remembering a little bit about parabolas, you know it's going to be the vertex is moved down 1, and then you're going to go up 1 over 1, and up, or excuse me, over 4 and up, or excuse me, keep that graph going very similar to this with this parabola. So when you look at the that's the relation. Now we want to graph the function. Let's take a look. Let's inverse this, and we're going to have x equals just like before, y squared minus 1. Subtract, or excuse me, add 1 to both sides, and then take the square root of both sides. The plus and minus of the square root of x plus 1 is going to equal y. Now let's start plugging some values in. Remember, we had to find out ways to create a perfect square here. So if we just plugged in some values, let's see what happens. I need to create a 0 in here. so that's going to be negative 1. That's going to spit out a 0. If I plug in a 3 in here, or excuse me, a 3 in here, that'll become a 4. Square root of 4 is 2. If I plug in an 8 here, I'm going to get 9. Square root of 9 is 3. Now, let's go ahead and graph these. Negative 1 and 0. Negative 1 and 0. 3, 2. 3, 2. Then 8, 3. So this point matches, and it looks like we're doing the same kind of parabola as they had before, but we're missing it down here. So now the question is, why are we missing part of this graph? If you think about it, the answer is right here in the plus or minus. So we're going to go ahead and look at 0. 3 is going to spit out positive 2, and then also a negative 2 because of the plus and minus. 8 is going to spit out a positive 3, and then also a negative 3. So let's graph those other points. 3, negative 2, 3, negative 2, and then 8, negative 3. 8, negative 3. And those are going to be the other parts of our parabola. Sorry I'm not the best artist, but hopefully we get the idea that we're flipping over this graph. Now there's one other way we could have gone ahead and solved this. Let's take a look at that. Since we're always switching out the x's and y's for the inverse, let's take a look at our original function, y equals x squared minus 1. So if we were to go ahead and plug in some values here, let's just take the Fab 5. 0, 1, 2, negative 1, and negative 2. If I plug in 0, it's going to spit out a negative 1. Plug in 1 here, it's going to be 0. If I plug in 2, it's going to be 4 minus 3, or 4 minus 1, which is 3. If I plug in negative 1, negative 1 squared is 1. 1 minus 1 is 0. And negative 2, square that's going to become 4. 4 minus 1 is going to be 3 again. So what we can do is go ahead and plot these points. 0, negative 1. 1, 0. 2, 3. Negative 1, 0. Negative 2, 3. And get our little parabola that way. Fine. Just make your dot bigger, guys. Now, we didn't even have to worry about writing the inverse of this because we can just switch out the x's and y's. So now that we're going to have an inverse, our x values are going to be all of these. And all our y values are going to be the former x's. Negative 1 and negative 2. Then we get to plot those. Negative 1, 0. 0, 1. 3, 2. 0, negative 1. And 3, negative 2. And now you've got your inverse. It's all about switching out the x's and y's. We'll see you guys tomorrow.